Hello everyone, I hope you're okay. It's been such a long time since I did a video, and I've been meaning to do a video for quite some time, but you know how things get, there's so much going on, and yeah, I just never got round to it. Anyway, the last video that I did that I remember is to do with testing the capacity of a lead acid battery, and I still need to do this. Basically it's to do with the solar power system. I want to check the batteries because it's been a long time now, and I want to see if they do hold their charge still. I suspect that they're all damaged, but we'll see. Anyway, so I've shown you the code for that and I've shown you the design. Since then I've designed a PCB, and I've had this PCB made for me and supplied for free. As is sometimes the case with YouTube, a lot of companies like you to mention their name, and therefore you can get free stuff. Anyway, of course I appreciate that. The name of the guy who supplied these is called Bean, and he works for nextpcb.com. nextpcb.com. So if you want to go and check them out, please feel free. I'm just going to show you the quality of their boards. So here we go. So I've got these PCBs. By the way, I mean there's quite a number here, and I might put these on my eBay shop because I don't need this many, and you know I probably won't be making any profit on them, but you may as well use them. But first, I guess we'll have to test if they work, and that would be because of my design potentially. Maybe I've messed up. It's always possible. But if they do work, yeah, I'll probably put them on my eBay shop, and I might put a link in. How many have I got here? 1, 2, 3, 4, 5, 6. I've probably got about 10. It does say 10 on it. And you know, I'll probably just cover costs and whatever. So if you want to, you know, give this project a go, then they may be very helpful. So here's the board which I designed. And as you can see, they've actually done a very nice job. It's a very nice looking board. Perfect quality. Yep. So there you have it, nextpcb.com if you want to check them out. Now regarding the actual design, I've soldered it up already. So here's the PCB. I think I'll just zoom in to show you a bit better. You may have to re-familiarise yourself with it if you've, you know, if you want to, because it's been a long time since the video was posted, the old video. But essentially, we have a heatsink and a fan. It's very dirty, I know. A high power resistor, which is a 100 watt 8 ohm resistor. Then the circuitry on the board, essentially. What it is it's a NPN, well, actually I should say an N-channel MOSFET. That's an N-channel MOSFET. And what it does is the gate is driven by one of the pins here, and it basically closes the circuit, which allows power to run through the cable straight through the high power resistor and back. And because I know the resistance of this resistor and various other factors, I'm therefore able to calculate the amount of current which is going through. And of course capacity is a measurement of current versus time in this particular subject, if you like. So I've got the start and the stop buttons, a capacitor there. I can't remember why that's there now, but I've also got the screen, the LCD. There was a little problem here actually. What I'd done, it's not very professional, I'll admit, but what I'd done is that I didn't want this to be powered from USB. I wanted it to be powered from the 12 volt battery. And really, when it comes to testing capacities of large batteries, that's fine. The reason it's fine is because the nano and these components here consume hardly any electricity, and it wouldn't really make a bearing on the result, because if you're testing a car battery which is 50-60 amp hour, a few milliamps isn't going to make any difference. So therefore I was able to avoid having to get an external power supply. Right, anyway, so I've digressed quite a lot. So the problem was, I had the 12 volt input here, and you could put it to the V-in pin, but I didn't want to do that. I wanted to send 6 volts to the V-in pin. So to do that, what I did is I made a very simple voltage divider with again, heavy duty resistors, 1 watt, 2 watt, etc. resistors, not just these little signal resistors that are below here. And what I wanted to do was resist off half of the voltage, so resist off half of the 12 volts, and therefore feed 6 volts to the VIN pin. But it didn't actually go to plan. It did in the mock-up that I did in the breadboard, but it doesn't on here. I'm not exactly sure why, but I just fixed it anyway. So what happened is that if it was 12 volts, you'd expect 6 volts to go into the V-in pin, which is the minimum that you want really, because there's an AMS 1115, I think it is, 1117 is it, voltage regulator, and that needs 6 volts to work. However, what was happening is that for whatever reason, around about 5.5 volts was going to the V-in pin. So what I did is I changed the voltage divider here from a 50-50 ratio, in other words 160 ohm and 160 ohm. I changed it to something like 80 ohm and 160 ohm. So basically 1/3 gets resisted off and the rest goes to the VIN pin. So basically I expect 8 volts to go to the VIN pin now, and 8 volts is fine for the voltage regulator below here to get an accurate and nice 5 volt input. So I fixed that. Everything else is according to the same design as I'd previously shown you. Anyway, what I want to do now is show you this thing working. So if I just get a battery, I don't actually know how many volts this battery is, so I'll need to check that. Let's have a look. 20. How many volts is this? 12.5. Okay, that's fine. 12.5 volts. This is just one of those little 7 amp hour things. And a 6.5 amp hour. That's fine. So 6.5 amp hour. Bring this back. Yeah, I've got these things. They're actually too heavy duty, I'd say, because if you see how stiff they are, Anyway, so let's connect these up. We've got 1 and 2. And you should be able to see the thing light up. Yep, it has lit up. Oh, this is another thing I've got to be careful of. I've not snipped these off yet. You see the underneath here? In fact, yeah, I'm going to disconnect that. I've not snipped the underneath of the PCB off. And of course that's potentially quite dangerous. Well, for the circuit it is anyway, not for me, but for the circuit. And I haven't got any snips to hand, and yeah, so I'm going to do that. Of course I don't advise this, but that's what I'm doing. Now connect this back up. Excuse me. And it says press to start. Too much light on that, isn't there? Press to start. Maybe if I do something like that. Oh well. Right, press to start. And it says, well, you can see for yourself there. It claims to be drawing 1.72 amps, and it claims that the current voltage is 12.96 volts. Now, 12.96 volts, I don't think that's right. Let me just double check. Wasn't it 12.5 volts? Okay, so it's obviously not right. And the first place to start, in my opinion, is to check the system voltage, because according to the code, if the system voltage is not right, it can't possibly get a correct result. So the first thing I need to try is that. So look at this here, because these cables here are heavy duty. It pulls the board up, and these wires are so short here that this is also attached to it. So you've kind of got to struggle with two heavy weights with a very light board. What I'm going to have to do at some point, I suppose, is make these little blue wires longer, but then of course you don't want them too long, because you know they've got to go through this resistor here, and it's going to be 2 or 3 amps. So anyway, so what do we want to check? We want to check the 5 volt value. So 5 volts to ground, and we have, where's 5 volts there? 4.72 volts. So yeah, it's not right. I wonder if that drops. Yeah, 4.54, it's definitely not right. But that's interesting. The problem I just mentioned to you before about the voltage in is this exact same problem. So how's this happened? That's an 80 ohm resistor there, and that's 160. So you would have thought a third would drop across here and go to the V in pin. So the V in pin should have 8 volts, so I wonder why it's not got 8 volts. So there's some sort of problem here with the V in pin. So it should be 12 volts in. And where does the 12 volts go? 12 volts goes down underneath here to a voltage divider, and that voltage divider resists off 2/3, and then it resists off the 1/3. I can see that because there's a 10k resistor there and a 5k, and in between the two it goes to the A0 pin. So the problem is not there, at least I wouldn't have thought so. On the same line here, the power rail, this power rail over here, we have it going to the load and coming back from the load here, and it gets switched by the transistor. I don't think that's anything to do with it either. Sorry, not transistor, a MOSFET. The problem is up here somewhere. So we get the 12 volts in, then it goes to this resistor here, which is 80 ohm, and it comes back through the 160 ohm to ground. The ground connection's fine. Or is it? I wonder if I was to test the resistances. I mean, I know you shouldn't really be testing resistances when components are in place, but I think I'll try it anyway and just see what it says. So this one I expect to be 80 ohms. Yeah, it says 80 ohms, yeah. This one should be 160. Yeah, 160. Okay, I'll check the resistance between here and here. No resistance, so it's connected. This puzzles me. Yeah. I'm not seeing any reason as to why that's not 8 volts going into here. Now there are things I could do with this. I could pretty much take this resistor out and it would probably work. But the problem is then it would feed 12 volts or 13 volts to the VIN pin. I'm not sure if that's ideal really. I mean, because what it would mean is that this voltage regulator would have to regulate down from 12 volts, which I'm not sure if it would be able to do that. I could Google it. 1 second, let me Google it. Okay, according to this it says 15 volts. Let's put 15 volts. Maybe I should just do it. I'll take the resistors out and see if it works then. Okay, so I have it working. What I did in the end was I took out the bottom half of the voltage divider. Yeah, so the 2/3 of the voltage divider, the ground side. So I took out that resistor. So now what I have is I have the 12 volts in, or the 13 volts in, or whatever it is. And I go through this resistor here, which I was going to take it out really, but then I noticed, of course, that if I took it out I'd have to bridge it with something. So I left this in place, and this is was it an 80 ohm resistor, I think? Probably something like that. And then from there we go to V in. And actually this works well, because this just takes the edge off the voltage regulator. This resists off some of them anyway. It wasn't intentional, but it does. So yeah, what we have now is we have the 12 or 13 volts in, whatever it is, through this resistor. This resistor drops a small amount of voltage, and then the V-in pin has the rest. So probably about 9 volts, and then we go from there, and it works. So I'm going to show you now. So let's restart this. I'm just going to connect the probes to the battery. There we go. So it's saying straight away 12.34. Now the thing is, if it's 12.34, this will be happy to drain it. But as soon as we apply 2 amps, it's going to pull the voltage down straight away, voltage sag. And it may well pull it down below 12, and if it does pull it down below 12, this will stop working. But anyway, at least we can see. Let's see what it does. Yeah. So you see what happened there? The last voltage it read was 11.98, and this did sag. So if I try it again, you'll see this sag straight away. So here's the voltage of the battery. This is what it thinks the voltage is at the time when it polls. Now, so what should happen here, what should happen is that as soon as I press this, this should go to 12. I don't know, 1 or something. Well, ideally 12.33, and then probably within a split second after the load is applied, it will go down to 11 point something, and that's the point where this cuts off. Now when this cuts off, it remembers the last voltage, but as soon as it cuts off, this voltage here will spring back up, because that's the way voltage works. As soon as you release a load, it's a bit elastic, if that makes sense. Anyway, so let's go for it. So we want a high voltage, a low voltage, and then as soon as it stops, it should spring back up. 12.17, you see? Yeah, it's shot down and it's gone back up after the load stops, so that's perfect. Now, regarding the accuracy, it seems quite accurate to me, but what I'd have to do is I'd have to connect it to something with a known voltage. Again, same thing. When I press start, the voltage is going to sag, depending on the amount of power that's available to it. This won't sag much because it's a 5 amp DC power supply. But let's see. Alright, so it thinks the current voltage is 13.18. My meter says 13.24. So it's 60 millivolts out, and I think that's acceptable, really. Yeah, I think that's acceptable. So what is it saying? 13.18 volts, and because it knows the resistance of this, which I can't remember what the resistance is, 8 ohms. Yeah, it's saying 1.76 amps. So I'm just going to try that. Just test that with my calculator. I'll zoom in for you as well. And right now the resistor's getting quite hot. Calculator, where's calculator on this phone? There we go. 13.18 divided by 8 ohms. It's not actually 8 though, is it? It's like 7 point something, but I'll try 8 anyway. Divided by 8 equals 1.64 amps. Yeah, but it's not 8. I think it was 7 point Let's try something else. 13.18 divided by 7. I think it seems to remember it was 7.5, and that says 1.76 amps, and that's what that says as well. So yeah, it's certainly not far off. Yep, it's not far off. So the idea is now that I'd let this run. So now I've verified that it's working, what I'll need to do is I need to clip these leads off here, and then do something with these here to stop them moving around, because that will result in corruption. So probably I'll isolate this here, sorry, insulate, not isolate, and then I might hot glue the LCD. Hang on, I can barely hear myself talk with this. That's it, and I might glue the LCD to here, something like that. I may also make these blue wires a little bit longer as well, because there's a pain like that. Yeah. This could be screwed down to a piece of wood or something to stop it moving. That's what I'll probably do. And then one of the next videos that I do will probably be testing the capacity of those solar batteries. Yeah. Anyway, thanks for watching. Bye.